So just need to finish the last part of lesson 3, and then we're going to do lesson 4 in the same video, mostly because I just recorded this and the mic wasn't on, so I'm going to go do this one more time. So when we're doing this piece here, we are looking at combining reflections, just seeing how it moves and where it goes. Just kind of look at the end game is important here. So we are trying to build the negative f of negative x. So essentially you see you have a reflection over the x and the y. And what we're going to show you here first is that it doesn't matter the order of those, and that's kind of a spoiler alert. So I'm going to go a little bit quicker through this because I think this is pretty basic. But if you look at it here, the first thing is if we're going negative f of x, the first thing it is they're going to do a reflection over the x-axis. Reflection over the x-axis is the negative f of x piece. So that would be this piece. Okay. So in the negative f of x piece, we know that's a reflection over the x-axis, which we change our y to a negative y. So here's the original, and then after step 1, we're down here. We reflected over the x-axis by switching our y to negative y. And the second thing we're going to do is we're going to do our x to negative x, which gives us a negative, we're going to put that negative x right there, which flipped us over the y-axis. And so we're going to go from 1 to 2. And so this is your lasting image. Okay? Now we're going to do the same exact thing, but reverse order in this other table. So we're going to go reflect over the y-axis. So we're going to change our x to a negative x. So we're going, first we're doing this piece. Okay, so we're going to go over here, there, there, and there. That's where it's going to be for the step 1. So step 1, the original. Then we reflect over the x-axis. So we're going to go from y to negative y, and we're going to get the negative f of negative x now, which is going to flip over here, the x-axis. So down 3, 6, and we're going to be here. If you look above, obviously my lines aren't great, but if you look above, it's the exact same position. So on the grid above, sketch the image, we just did that. There's an order in which reflections carried out affect the final image. It does not. So what we're saying is if you see negative f of negative x reflection, it doesn't matter which one you do first. You can do the x flip first, you can do the y reflection first, it doesn't matter. Okay, describe the two sets that you can do. So we can do, these are pretty basic here, but we'll go ahead and talk about it. We can do reflect. So you can do reflect over reflect x, then y. Or you can reflect y, then x. Okay? So 2 options there. Okay, and we're just going to do a couple with the inverse now. Okay, so I'll go a little slower with the inverse ones. Just because the inverse I think is a little more complicated, but let's go and look at these 4 charts, and then we'll answer the questions at the bottom. So we're going to go ahead and just do what it tells us. We're going to reflect in the x-axis, or y-axis, excuse me. So reflecting in the y-axis, we know that means we're going x to negative x. So that means our function, with our regular function, is going to be this now. So I'm going to do that first step right below. I'm reflecting over the y-axis, so I'm going to be here, here, here. Okay, so there we are. And then reflect over the y equals x. Now just kind of visualize this. See, here's my y equals x line for my inverse flip, right? So I kind of expect this to probably land somewhere in this region here. Okay, so we know if we're doing reflection y equals x, we go x to y and y's to x, signifying that they flip spaced like spots. And so remember, this right here is y equals f of negative x. So now we're going to write it x equals f of negative y. Okay, x equals f of negative y. So we're just flipping it. So we have, I just do the points because we're not given the actual equation. It's negative 1, 3, so I want 3, negative 1. Okay, then negative 3, 3, so that's right here. And then it's negative 2, 6, so I want 6, negative 2, so it's right here. So this is where it's going to be. That's our new spot for x of f of negative y. Okay? All right, so let's look at the next one here. It's going to be a little bit different. So we're going to do reflection in the y equals x. So right away we're flipping our x and y and our y to x. So that means our equation goes right away, goes to x equals f of y. Okay? So we're going to go ahead and flip this now over the y equals x line. So you can see, if you remember, last class, talking about invariant points, that's at 3, 3. If I do the inverse of that, it's still going to be there. So this point's not going to change. Okay, but the other ones will. I got 1, 3, so I'm going to be at 3, 1. And then I have 2, 6, I'm going to be at 6, 2. So right here is the first position move. And then we're going to reflect over the y-axis. So that means that we're expecting this to be over here. Okay, because it's going to flip over the y. So if we do that, we know we're going from positive x to a negative x. And so that means we're going to go x. So if it's going to end up being a negative x, which means if we want the x to be positive, we're just going to make it a negative function of y. So we're flipping the function of f of y. So we do that, we're going to be over here. It's essentially just going to swap right over. And 3 here, here. So that's where it's going to be. Okay. Okay, I'm going to lose these. You got to make sure to refer to these for these next two, and then when we get to the questions at the bottom. Okay. All right. So transformation, now we're going to go from reflection the x-axis. So if we're doing x-axis, that's y to negative y. Okay, and so that means we are going to have y equals negative f of x right now. And so that means this originally flipping over the x-axis, so we're flipping down. Okay, so that means we're going to be right about here, here, and here. So that's where your next spot is after that move. Flipped it down. And then we're going to do the y equals x line. So if you see, again, if you just kind of roughly think about it, that means we're looking at being right about somewhere in this region. Okay, we'll see how it works. So remember, y equals x makes x go to y's and y go to x's. And so with our function, it's going to be x equals negative f of y, which we already have at the top. Okay, the top right is where we got that one. So you're going to see it's going to end up being in the same exact spot. So this, so if I'll do it, it's going to be 2, negative 6. That means I want negative 6, 2. So it's right there. And they're end up going to flip. It's going to be 3, 1. It's going to be right there. If you flip the points, and you can see this is the same as the one we just did up there above that graph. And they ended up being in the same location. You'll need that for the bottom here to finish these notes. Reflection y equals x. So again, just write for practice. X goes to y goes to x. So x equals f of y. Reflection in the x-axis. Okay, so reflection in the x-axis means that we're changing our y to a negative y. And so it's going to be x equals f of negative y, which is like the graph on the top left. Okay, so let's see. Let's go ahead and up. I did the table all first, sorry. So we'll go and do the graph here. So the first thing when I reflect over x is y, again, we have that invariant point here of 3, 3. So this point stays the same right there. And then this point's just going to shift to here. And then we're going to have this point there for, oh, sorry, a little too far, for 6. So there we are. That's our first move for step 1. Our step 2, now we're going over the x-axis, so we're going to flip it down. So that means we're going to have a point here, a point here, a point there. And so that's where that image is going to be for its final location, just like it was for the top left. Okay, so you can see what they're talking about here. Let's try to highlight this a little bit. So see the end game here? They're asking that for, that's this one. Okay, and this one here is this one. So they're saying, how are the two ways you get those? So the two ways you get those are these two steps with the top left, these two steps with the top right graph. Those are the two steps. So we're just going to list those now. I'm going to move it up. My stuff's going to be gone, so refer to yours, and then we'll be done here. So how do you get to be x equals f of negative y? There's two processes. Process 1. Reflect the y-axis y equals x. 2. Reflect y equals x line, then x-axis. Okay, that's for the x equals f of negative y. For the x equals negative f of y, you can reflect the x-axis, then y equals x. You can kind of see the relationship here, how they're just kind of flipped. Or you can do y equals x line first, then the y-axis. Okay. All right, and that's all for this one. So I'll pause the video for a second, but we're going to go ahead and add on lesson 4 to this as it's quite short. Okay, so just continuing. So this is Unit 2, Lesson 4, so the second part of reflections. I don't really have to review this because we just did this. We literally just talked about it in this video, so that's just the review for this. Let's go through some examples, though. So write the equation of the image of y equals x squared after reflection over y equals x. So we know that that means that when you reflect over y equals x, you're switching x and y. So that just means that it's going to essentially be, well, x equals y squared. And if we want the equation in terms of y, then we would square root. So y would equal plus or minus root x. That would be the equation for that reflection. Y equals 10x after the reflection of the y-axis. So we know with the reflection of the y-axis, we change our x to negative. That's our tracking. So that just means it's going to be y equals 10 to the negative x. And y equals root x after reflection in the x-axis. So that means that we're making our y negative. And so then we just essentially are going to flip the sign over to get y by itself. So y equals negative root x. Okay? This is all stuff just building off our movements of reflections from last time. Describe how the graph of the second function compares to the graph of the first function. So x cubed, negative x cubed. So we see the negative in front, so we are thinking that that means it could, for this one we got to pay attention to two things. One, it's odd, so that could mean actually two things. It could either be negative f of x, which is reflect on the x-axis, or it could be this as well. Because if I put a negative x into an x cubed, that gets me a negative in front there. So actually both of these reflections could be something that we notice. Just identifying they're both possible. So from x cubed to negative x cubed, it could be reflect over the x-axis or reflect over the y-axis. Both are possible. This one is kind of straightforward. You see the x and the y were swapped. So since the x and y were swapped, then we kind of understand that that means it flipped over the y equals x line. So it's the inverse. Okay. And the second one, it looks like everything, the y's stayed in the same spot, the x's were just changed. So that just means it went to f of negative x. Okay. So that means for us it's a reflection on the y. Okay, it's like really short here, so let's finish this up after we've got this little piece and a couple more examples. All right, so the graph drawn in the thick line is a transformation of the graph in the thin line, so the thin line is the original. Write an equation for each graph, draw the line in terms of being thick. So we got x squared. Okay, so what do you think it reflected over? How do you think it did? Well, it looks to me like, if you think about it, definitely did a turn. Kind of whenever you see a turn, to me, I immediately think the inverse, and that is the case here. As you can see, these are reflecting inverse relation. So when we're looking at that, if we have y equals x squared, that means that it went from y equals x squared, the new one is x equals y squared, and we're going to solve, which gives us y equals plus or minus root x. which is not a function, as we know, because it's a turned parabola, which doesn't pass the vertical line test, because it does ask if it's a function or not. Okay. Next one, we have a v. The v flips down. So essentially, it flips down vertically. So then for us, if it flips down vertically, that was over the x-axis. So in our case, we think that that means we want to flip the that means it's going to be y equals negative f of x, the whole function flipped. Okay, and so that gives me y equals negative root of absolute value of x, which makes all the v's negative. That's how I got down there, which it is a function. Okay, pen's not working too good today. Okay, just two more examples. All right, so sketch the graph of f of x equals 6 over x squared plus 3. So we can sketch that first. You can just plot some points if you want. There is no ways to get 0 on the bottom, because the only way to get 0 on the bottom if the x squared could be negative 3, which it never will be. So if you're starting to think about asymptotes and stuff, just slow down a bit. We're not doing that yet. So let's go ahead and just graph it in terms of so it's going to look something. See, if I put 0 in, I get 2, and then it's going to filter down like something like this from there. You can plug in a couple points if you want. If you plug in 1, you're going to get 1 squared plus 3 is 4. 6 over 4 is 3 halves. So that's why half. This is at 1 1/2. Negative 1, the same thing. It is mirrored because you're squaring everything. So every time you put a negative, it's the same thing as a positive. So now what we're going to do is we're going to do y equals negative f of x. So that should reflect it over the x-axis. Okay? And what that does is since it's a negative f of x, it means all outputs, if you want to think about it, all outputs are switched to negative. So all these y values that we have here between 2 and 0 are flipped to negative. So it's just going to be down, oops, it's over here, sorry. It's going to be down here and going this way. Okay? Same thing, but just flip down. Now, what's going to happen when I flip the x's on this? Well, if you look, it is exactly symmetric like a parabola here. And so if I flip over the y-axis, it's going to be the same. So this picture should be the exact same as this one. So 2, go and tailor down, go and tailor down. Okay, that's it. And how about the inverse? Now that's going to be a little bit weird. Okay, so let's go and look at that. So kind of what happens is I would just think about it in terms of points. If we look at terms of points, we are going to go ahead and swap the points. But let's see here. I'm forgetting to put the equations here. I'm just going right to the pictures. Sorry. So let's get the equation real quick. So the negative in front just means what I have is just going to be negative. So it's just going to be this. Okay. If I do a negative x, you're going to see it to be the same thing. So I put a negative x into the x squared, it's going to be squared, which makes it positive. So this is still going to be that. Okay, and then I do the other ones. I'll be a little bit messier for the one we're working on right now because we're going to go x equals 6 over y squared plus 3, and we're going to solve from there. So let's go ahead and do that. I'll probably need a little bit more room, but I'm going to multiply this over here to get it off the bottom. And so that's going to give me y squared plus 3 times x equals 6. Then I'm going to divide the x off. Okay. And then I have y squared plus 3 equals 6 over x. Then we minus the 3. And then we square root. And this will be the plus or minus there. Okay, so being the plus or minus is going to make it not a function. Okay, if you put that in your graphing calculator, or if you try to plot the points here, you're going to see that 0, 2. So now I'm going down here to the graph. Okay, so here's the functions. We got 1 graph, 2 graph. We're on the 3rd graph. If I take 0, 2, that's going to be at 2, 0. And then you can kind of see it's going to end up just being sideways. It's going to go like this Okay, a little bit more symmetric than mine is, but it goes that way, which kind of makes sense because if I take a point like this here, which is 2, 1, it's going to be 1, 2. 1, 2. And you kind of see it's on there. Okay. One more example. Okay, so given the function is 3x plus 2, determine x equals f of y. Okay, so x equals f of y means that we're going to go, that means we're flipping to make it the inverse. Okay, so we need the inverse of 3x plus 2. So by doing the inverse of 3x plus 2, we're going to go ahead and solve x equals 3y plus 2 for y. So it's x minus 2 equals 3y. So y equals x minus 2 over 3. So that's what that would end up being. If you want to write that as a nice linear equation, so you have your slope and your b, you can write it as 1/3 x, right? So the 1/3 with the x, and then 2/3. So 1/3 hits both terms. Okay. And then on the next one, if we're doing f of negative y, so that means we're going to end up flipping. And so we have to, remember, do our steps from earlier. So we have to go, we're going to do x of f of y. So we'll do this first. Just right in the previous lesson. You have to get this, how do we get these? Go look back at those 2 steps we just wrote down on this video. Okay, so we're going to do the reflect over the, we're going to do the y equals x line first. Okay. So that gets me x equals 3y plus 2. And we know when we solve that, we already know what that is. So we're going to get 1/3 x minus 2/3. And then we're going to, after that, we're going to flip the y to negative. Okay. So it's a little bit easier, it's a little bit easier to do the movements before you solve. Don't solve for y continuously. Continuously is not the right word, but don't solve for y right away. So we just switched to f of y here, and then from here we want to go ahead and do flip over the x-axis. Okay, that's one option. You can do the other one. I'm just going to do one. Y to negative y, so that just means it's going to be x equals 3 negative y plus 2. And now we can solve that for y. So x equals negative 3y plus 2. So we have x minus 2 is negative 3y. So y equals negative 2/3 x plus 2/3. 2/3, it's 1/3. So we divide it by 3 to the 1. Negative 1/3 x plus 2/3. Okay, so that's what that one is. Good. And let's try the other one here. So the same thing, you have the 2 options of steps from the previous lesson. So we are going to go ahead and stay with the same pattern. Let's go into the inverse first. So doing the inverse first for part 3, we are going to have the same exact thing. I'll just write x equals 3y plus 2. That's your step 1. And then after that, what are you supposed to do? Right, you're supposed to just do the opposite we just did before. Instead of negative x or negative y, it's going to be a negative x. So you're going to take x to negative x. And so what that does is it essentially flips the function. So if it's a negative x, we're going to distribute that over. So it's going to be negative 3y minus 2 now. That's an arrow here with a negative x. And so now we're going to solve for y again. So plus the 2, divide the negative 3. So we get y equals negative 1/3 x minus 2/3. So you can see they're a little bit different. Okay, and I want you to graph these here. So this one here is going to be 1/3 x minus 2/3. So minus 2/3, I'm just going to be right about there. And it's down 1 or up 1 over 3. So it's going to be about here. It's going to be something along these lines. No pun intended. Okay. This one here, negative 1/3 plus 2/3, so plus 2/3 would be here, a little bit higher there. Down 1 over 3, so this one looks something like that. And then the last one there, negative 2/3, negative 1/3, here, a little bit higher, down 1 over 3, so it's going to be more like this, going that way. Okay, so you can see that 2 and 3 are pretty close, just their y-intercept was different was all. They both had a negative 1/3 slope. Okay, that's all for lessons 3 and 4.